Hello everyone, welcome to Recitation 0B. In this video, we are going to cover section 5, which is about how to combine data in Numpy. First, concatenation. So a concatenation operation basically joins a sequence of arrays along an existing axis. All arrays must either have the same shape, except in the concatenated dimension, or be empty. So say that we have two arrays, one with dimensions 2, 2, and the other with dimensions 1, 2. So if we try to concatenate these two arrays all on axis 0, note that this is a valid operation since these two arrays have a matching shape along axis 1. So it's basically all axes except for axis 0. So the resulting array would have dimensions 3, 2, which is basically adding 2 and 1 along axis 0. And say that we want to concatenate these two arrays along axis 1, this would be invalid since these two arrays have different sizes along axis 0. So if we try to do this, notice that here we would have an error saying that like these two arrays have different shape along axis 0. So we do not want to do that. And over here, we have a similar example, except we have more dimensions. So since these two arrays have exactly the same shape, we can basically concatenate them along all three axes. And feel free to make a pause here and try to calculate by yourself what would we expect these three concatenated arrays be. And basically, when we try to concatenate these two arrays along axis 0, we would get shape 3, 4, 5. So we basically add the shapes along axis 0. Similarly, for array 2, we have shape 3, 8, and 5. And for array 3, we have 3, 4, and 10. Moving on to stacking, the stack operation joins a sequence of arrays along a new axis. So this axis parameter specifies the index of the new axis in the dimensions of the result. All arrays have to be of the same size since we are creating a new axis, and the stack array has one more dimension than the input arrays. So say that we have two arrays, which is of the same shape, 3. When we try to stack them along axis 0, we would get an array of dimension 2, 3. So basically, we stack these two arrays along axis 0. So this new generated axis would be axis 0. And if we try to stack these two arrays along axis 1, the resulting shape would be 3, 2 instead. And it's the same thing when we have axis -1. So when we have axis equals to -1, it's basically trying to, like this newly generated axis would be the last dimension, which is the same thing as having axis equals to 1 here. Similarly, we have here two arrays of dimensions 3, 4, 5. So notice the location where this shape 2 comes up. Basically, it's corresponding to the location or the axis that we specify here. So this would be the newly generated axis. And at last, we have repeat. So the repeat operation basically repeats elements of an array. The number of repetitions for each element is broadcasted to feed the shape of the given axis. The axis parameter specifies along which axis to repeat values. By default, it uses a flattened input array and return a flat output array. So say that we have an original array of shape 2, 2 with value 1, 2, 3, 4. If we try to repeat this original array with repeats value 2 without specifying any axis, it would first try to flatten this array. So we have an array of shape 4 with value 1, 2, 3, 4, and then it would repeat each value twice. So what we get here is an array of shape 8 with value 1, 1, 2, 2, 3, 3, 4, 4. And here's an example with specifying access. So say that we have access equal to 0. What it would do instead would be it would repeat along the specifying access. So here, what we would get would be an array repeating each inner array with the specifying repeat value 3. And similarly, here we would try to repeat the original array along axis 1, which has shape 2, 6 here. And this repeats value can also be an array, but notice that here it has to be matched with the number of elements in the specifying axis. So here, if we try to repeat the array along axis 0, this 2 here would correspond to the number of times we want the first inner sequence to be repeated, and 3 would correspond to the number of times the second inner sequence be repeated. So here what we got is a resulting repeated array of shape 5, 2.